Hi, Physics 30. I'm going to run through a diffraction example here. And this is a good example because we're actually going to ask how many lines per centimeter are in a diffraction grating. All right, so I got 600 nanometer light, screen's 2 meters away, and the distance between antinodes is 1.5 centimeters. I'll deal with that first. That's not going to be too hard to wrap our heads around. So antinodes are all equally spaced. If we say this is the central one, it's just going to be 1.5 centimeters to the next one, which would be n equals 1. So what we can do is use one of our formulas for constructive interference, since these are antinodes. It's going to look like that. And I'll just use n equals 1 when the spacing is 1.5 centimeters. Okay? So in order to get the number of lines per centimeter in a diffraction grating, we're first going to need to know how far these lines are spaced, and that will be x in our formula. So let me just shuffle this around. Okay, so explicitly finding x, it's going to be n, which is just 1. I didn't need to write that, times L times the wavelength divided by d. Okay, so d, I totally messed this up. I mentioned in class I mix up x and d all the time, but it doesn't actually matter. All right, I'm going to keep this video going. I'm not editing this. So I'm actually looking for d. I mix those up all the time, and d is going to be n L lambda over x. So it doesn't actually matter that I mixed these up. Okay, I still would have got the right answer, but let's do it the right way. So I'm finding d. D is going to be the spacing between the lines in the diffraction grating, and that's what I got to get. So let me write this out. N is just 1. Distance to the screen was 2 meters. Our wavelength is 600 nanometers. That's going to be times 10 to the negative 9. Okay, and x here is our 0.015 meters. Okay, so when I calculate this, I'm getting a spacing of 8 times 10 to the negative 5 meters. Okay. Now, at some point we're going to need centimeters. We could find the lines per meter and then divide by 100 to get lines per centimeter, or we could multiply this by 100 to get centimeters. I think that's what I'm going to do. So if I multiply by 100, I'll get 8 times 10 to the negative 3 centimeters. All right. And just a reminder, we're usually going from lines per centimeter to centimeters between lines, and you just do the invert, 1 over, same deal. So the lines per centimeter, what we're looking for, is just going to be 1 over this value. Okay, so that's going to finish this question up. And I got 125. Alright, sorry for the rough start to the video, but I hope it's helpful in the end.